Test. Okay, oh, I see. It's echo. All right. Hello. Some of you might know that Oh, I need to. Anyway, some of you might know that I'm not doing Advent of Code live this year. I thought about it and basically I wanted to try something different. This work. I wanted to try streaming them in little batches after the fact, and instead of just only going fast, try to narrate my thought process while doing them. I'm hoping this will be more fun and more educational. But also it's something that I wanted to try practicing and just experimenting with, see if I can do anything cool with that. I've not looked at the problems. I'm not completely unspoiled. I've seen glimpses of some discussion in memes, but I'm going in totally blind otherwise. And I also haven't I went over my Python setup to get this working well, but I haven't written Python on my personal computer in possibly months, so this will be fun. Okay, let me make sure I have a terminal ready. Oh, I had a command for this actually. Cool. Let's get input and try it out. We have a calibration document. The first digit and the last digit. Okay. So we want to get just extract all the digits, and then we're gonna go first star last, and then we have a sum, and so okay, that didn't work. At least two got one. Okay, so it's possible. Okay, so it's possible that there's only one digit. So you still get the percentage. And no, it's because of that. What's the answer? Yes. Yeah. Okay. So yeah, I tried to use. Okay, I didn't actually think this through. Also count as valid digits. Yeah, I tried to use the fancy destructuring to get the first and last, but that only works when it's two or longer. Okay, so now, I mean, we have to turn these into spelled out digits, so it's typing these out is too hard, so I'm gonna split by. I'm gonna probably use a replace method to just replace these digits in each line. Just go through one by one and replace them, and I hope they don't overlap. That would be, oh, that's quite toxic. Okay. Yeah, so, oh, that's quite rude. So the best way to do this. Wow, okay. So my plan, is I'm gonna take each of these strings W and just turn into 2W, and then I can't do all this in a single replacement because it's possible that they basically, this means that if we have 2W, well, this will become 2W, one, and it will still work. Okay, so but we just need to sort of iterate until we stop replacing then. So This is pretty ugly. Word in. You replace everything. This is a really awful way to do this. It's probably not the best. Stop the wrong thing. And then so now we've, yeah. How confident are we? Very unconfident. Yeah, this didn't work. Oh, this didn't work. Wait, just didn't, wait. Oh, equals. Okay. Huh. That's, what? It's exploding. Oh. Wait, that's not at all what I want to do here. Okay, how do we do this? Whatever, it's fine. Okay. Where's Neuralith? Yeah, that's a good question. I thought that, like, you know, using a real language would be more educational. But like, if like chat really wants to see me write Neuralith, that's like fine, great. Now we're gonna, anyway, we have to debug because I use a stupid algorithm that like is awful. This doesn't actually, okay, yeah, this doesn't actually do the thing I wanted to do because, oh, okay, yeah. This, because if I replace TW, okay. Yeah, I picked a pretty dumb algorithm. Find. I'm just gonna, just go through each index. You know, this is for eyes. Do I need that? Yeah, okay. I'm just gonna find all the digits if C. Okay, L if, and then we're just gonna check like the substring. So for each possible digit, if we find this word at location I, and it's fine if the slice goes out of bounds because it will just slice down to long enough thing. But this compare will work if and only if this word appears at the location I in line. In that case, to just stop and we'll keep it a string. We'll say we found the digit. I think this is fine. And then that's actually just what we want. 54100. Should I like test my code maybe? Nah, that's fine. Okay. Yeah, that would probably not, I assume that would not have made the leaderboard because slow. Day 2. This is the one where but we're gonna move on. I heard some things about parsing today. We'll see how it goes. Wow, thanks for the follow. Snow Island. So this, okay, I saw some things about cubes, but like didn't really get it. So we were playing a game. In the game, you like pull cubes from a bag. So you just want to see which of these is like a subset of this very oddly specific multi-set of cubes. So we can't just pull up the answer. So let's see. We're gonna start by pulling apart the game label and the sort of rest from this. I'm gonna split this by semicolon. Sub games. I'm gonna call them sub games. This way, and then one question is whether any of these sub games can include like a certain color more than once. Let's try to handle that. It's not outrageous. Split this, and then no for sub game in sub. So we're handling a multi-set here. This is a count. This is. There are going to be a lot of counters here. Does counter? Can I? This is. Can I less than equal to counter? Does that just work? I don't. Sub rich. Okay, that's good. Good. Okay, very good. So we can literally just. We're gonna start by. We're gonna have the reference counter where. Does this have to work? I'm going to like. Reference is red has 12, green has 13, blue has 14, and we have a multi-set. We're gonna compare every sub-game to this multi-set. Obviously part 2 is gonna be something totally different. But we'll do that for now. What did I call this? Word. It's not a word. Word.split. Color count is that. Count is int count. Game multi-set. Color count. Cool. If the multi-set is not less than ref, then we really want to okay, this is a little artificial, but if I should return false, true. So if the subgame is valid, how do we can use some library functions, but to get the game number out of that, the sum is 0. Sure. Cool. Okay, what is the actual game? The power. So we just that's fine. So we just need to deal with multi-sets. Okay. Okay. We're valid is a terrible name for this function. I'll fix it. Solve. We're just trying to get a solution. So we just want it. That's fine. Okay, yeah. So okay, multi-set. This is. Do we need this? I think we should. They probably won't actually give us any zeros, but that could have been a split. It would be like a second or two faster. But we're gonna just max this with the sub-game color return. And we know I have a product function, so we can just multiply them. That's not how you write multiply them together. We're going to return this. We're going to add these together still. That still works. That's way too low. That can't possibly be right. Oh wait, what? I didn't change this. No, what? That seemed a little small. Okay, whatever. We did it. 3. This is a grid. Lots of numbers, so we don't tickle numbers. Wow, we got some grid analysis. Oh boy. Okay, so we're going to find all the numbers that are adjacent to a symbol that's not a period. I want to look at the input. Okay. Are there any minus signs? Very funny if they're like, yeah, okay, so I'm gonna assume that this is like still +4. Does it say this so much? Yeah, okay. Very interesting. Hi, Tim Scar, thanks. Yeah, like I don't actually stream that much, but I was like, Admin Code is like, I don't know. I think it's something that I can actually provide like valuable stream for compared to everything out there. So I'm gonna try. Cool. Okay, this is so adjacent. Have we just? I forgot. I need to figure out, does diagonally adjacent count? Diagonally, yes, it does count. So I think this is yeah, this is kind of annoying. Okay, we're going to just find all the we need a sliding window of 3 lines at a time. In the middle of the window, we're gonna does that work? Yes. Okay, so we're gonna. Did I have a sliding? Did I write a? Surely I would have called it. But we're gonna take like a sliding window of it's not groups. We're gonna take a sliding window of 3 lines at a time, and then we're gonna look at the middle line. To make that work for the first and last lines, we're gonna prepend and append like full row of periods, and then for each number in the middle row, we're going to check like whether there are any I guess like non-digit, non-period things like next to it and in the line before and after it. So how do we do this? We're gonna make a dot buffer, right? And line 0 dots. Okay, so okay, yeah, we're gonna use a zip. I don't like I'm gonna not think about indexes. Okay, so I need some interesting regexing here. Give me what I want. Yes. Match object. Yeah, I need so for. No, I can do that. Num match in. We need the match object because we want to find the beginning and ending index to look things up with. We only want digits. We don't want the minus sign. Okay. That is not none. What does a match have? It has a group, which we'll use to get the number if relevant, but we mostly care about start and end. And we have to watch out for off by ones. We only need, okay, so. So we're gonna find where the match is. We're gonna look at the index, like, before it. So this slice is going to be the slice in which we look for any symbols. But for the start one specifically, we have to make sure it doesn't go to -1 or that triggers Pythonic negative indexing. But this lets us check. This is kind of silly, but for line in. How did I type that so poorly? I see. I just want booleans. This would be a small expression for C and C dot. That can't be a period, and it can't be a. So this is the expression we're going to use to check if there is a symbol existing. So for every line, every character in that slice, if that's true, we're gonna sum it up, right? That's what we want to do. S plus equals. It's not cool. Cool. And he's adjacent to. Oh, okay. So, in some ways, we got unlucky in that, like, we want to take a symbol and then find the things adjacent to it rather than the other way around. But not really, because like you have to avoid double counting anyway. Like you have to double count numbers anyway to do the first part. So I think this is salvageable. We're going to find, so for every number, so this is not a gear. So what's your I'm not a strong opinion. I don't know, like I've not personally gotten them like set up for coding. For LLMs, right? Yeah. I think it's cool what people are doing. I do research on them now, but like that's neither here nor there. Anyway, so what's the best? I'm gonna stick with this. This is so what we want to do. So we're gonna, whenever we find a number that's adjacent to a gear, we're going to like stick that number. We're gonna locate every gear. So we're gonna find every gear for. Now I need an index. Right. Okay. We have an index. This is terrible. I need to remember what this is. So it's row index. So for Now we're gonna for RI2. This is not good. RJ in rate. But we now need to keep track of row index for each line we look at. Starting at RI for C in current column J index in array line slice at that. So this C should be at index RJ CJ in the original. If so, we're gonna stick this number in association with this gear. And now the gear ratio is, so it's just a sum. You just product each pair in gears if they're exactly 2. Okay. We have bugs. It's time to print things, or is it time to just think really hard? Let's see, where are the likely issues? Oh, I see. Wait, no, that's not true. Like, I realize that prepending this thing makes the index like wrong, but every index should be off. Like, it won't reflect what was originally in the grid, but everything should be off in the same way, so that shouldn't matter. Start is not. Okay. Yeah, I don't immediately see the bug. What is my... I'm gonna try it on the... This will... Is it... That's not... What? Oh. Oh, that's embarrassing. That is the correct answer, so... And that's... Okay. That's all the problems we have so far. I want to take... it's fine. I will probably maybe see some of you in a few days for the next batch. Thanks for watching.